Hello everyone. In this video, we are going to understand the different methods of sampling. It is also known as sampling design or sampling techniques. When the secondary data is not available, the researcher for the undertaken study, the researcher has to collect primary data either by using census method or sample method. What is census and sample method? Census method is also known as complete enumeration survey method. Data are collected from each and every unit. Example can be person, household, shop, factory, and so on. The case may be of the it is also known as population or universe. That means the complete set of items which are of interest by the researcher. For example, uh, population is the collection of all individuals or items under the consideration in a statistical study. It is the definition given by WIS 1999. Let's assume that in our study, this is the population. The study can be anything. For example, let's assume that these are the workers in the particular factory we are interested to study. So in this case, for the researcher, these are the total population for him or her. Then what is known as sample? It is a small portion of the population selected for observation and analysis. So in this method, anyway, we are not going to collect data from every unit of the universe. Only a part of the universe is studied and conclusions are drawn on that basis for the entire universe. Of course, when we are collecting data from uh, all the population, the data obtained from each and every unit of the population is the advantage, and the results are obtained or likely to be more representative, accurate, and reliable. And uh, it also has its own advantages. However, the collecting when the population is too large, it takes lot of time as well as cost to collect data from each and every unit. So in that case, we have to depend sample, which is a subset of population units. So it is uh, relatively costless, timeless, as well as we can rely. And since we are collecting the portion of the unit universe, so we can collect more reliable and accurate data from the sample. So generally population is denoted by N, capital N. So let's assume that this is our population and sample is will be denoted by small n, and here there are few people only selected from the population. So these four are our sample now. So these four people are part of our population, so they are known as sample. So what is meant by sampling? It is the procedure of getting a small portion of the population from the population. How we are getting this small subset? So, what is the procedure we are following to get this small portion? It is known as sampling. So, we have to follow the scientific procedure to to obtain sample. What are the elements of sampling? First one, as we discussed, the selecting the sample itself is the very important part, because it's not that randomly we can select a sample. It has to follow certain scientific procedure, and collecting information from the sample and making an inference about the population. Though we are collecting data from the sample By using that sample analysis, we have to make inference about the population. So in this condition, what are the essentials of sampling? The sample should be representative of universe. Otherwise, the results obtained may be misleading. As we said, we are going to make inference about the population. So it should, the sample, whatever the sample we are selected, it should represent the population. And adequacy, the size of the sample should be adequate. Otherwise, it may not represent the characteristics of the population or universe. Independence, all items of the sample should be selected independently of one another. That means all the items of the universe should have the same chance of being selected in the sample. Here, the independence means the selection of a particular item in one draw should not have any influence on the probabilities of selection in another draw. Homogeneity. When we talk about homogeneity, it means that no basic difference in the nature of units of the universe and that of the sample. Uh, if two samples from the same universe are taken, they should give more or less the same unit. Sampling methods. Here we can see there are two types of sampling methods are there. One is probability sampling method, another one is a non-probability sampling method. Let's see first what is probability sampling method. In the probability sampling method, it gives each and every item in the population equal chances of being selected. And non-probability sampling method do not provide every item in the population equal chances of being selected. And again, probability sampling method, it's again divided into simple random or unrestricted random sampling method, restricted random sampling method. Again, restricted random sampling methods are divided into three parts, which is stratified random sampling, systematic random sampling, cluster sampling. Non-probability sampling methods are divided into convenient sampling method, judgment, quota, snowball. In the upcoming slides, we are going to deal all these methods in detail. What is simple random sampling method or unrestricted sampling method? Here, each and every unit of the population has given an equal opportunity of being selected in the sample. So, item gets selected in the sample is just a matter of chance. So, researcher personal bias will not have influence in the selection of the sample. So, every item has a probability of 1 by n of being drawn in at each selection. As we know, n is the capital N is the population. So in the second draw, 1 by n minus 1, and in the third draw, 1 by n minus 2. So it goes on. For example, in the random sample, selection of 20 students has to select from 50 student means each student has to be given an equal chance. The probability of selection here is 1 by 50. So there are two methods through which we can select this simple random sampling. One is lottery method, another one is table of random numbers. What is lottery method? Here, all the items of the universe or population are numbered or named on a separate slips of paper, which should be identical size, shape, and color. And all these papers should be folded and mixed up in a container, and blindfold selection should be made. And as many required number of sample size, the researcher has to select the slips. And why the size and shape should be homogeneous, because if it is not identical, it may create the prejudice or bias of the researcher. And this method becomes difficult as the population increases. So we have another method is known as table of random numbers. This table of random numbers generally obtained by a mechanism which when repeated a large number of items ensures approximately equal frequencies for the numbers from 0 to 9. And also some various combinations are available such as 0001, 999, and it goes on. But basically it expected in a random sequence of digit 0 to 9. There are several standard table of random numbers are available. For example, Tippett, Fisher, C.R. Rao, Mitra, and Mati. But the popular one is Tippett table of random numbers. Here, uh, we have given, for example, first 40 sets from Tippett's table as an illustration for the general appearance of random numbers. Suppose if we have to select the out of the units 100, we have to go up to 100. So accordingly we have to take the sets of random numbers. We have to select randomly first sample 001 and it goes up to 100. So next one, stratified random sampling. When the population is heterogeneous or different segments or strata with respect to the variable or characteristics undertaken by the study, then the stratified sampling technique can be applied to select a representative sample. And here, why it is known as stratified random? Because now first the population should be subdivided or stratified into different groups which should be mutually exclusive. That means that stratum should be homogeneous, and then draw a simple random sample from each group. So how to select this stratified random sampling? The based on that some base. That means that the strata will be created on the basis of a variable known to be correlated with the variable of interest, and for which the information on universe element is already known. Number of strata more than 6 is not desirable. Uh, Sample size within the strata, we can use either proportional or disproportional allocation. What is this proportional and disproportional allocation? The size of the sample selected from each subgroup is proportional to the size of that subgroup in the entire population. For example, uh, first strata n1 equal to n small n by capital N into capital N1. It means that in that subgroup, how much is the population, with that we are proportionating to the sample size. Similarly, it goes on N2 by N2 equal to N small n by capital N into second strata population. Whereas the disproportionate case, we are not considering the size of the subgroup. We are just selecting the sample from each subgroup is disproportional to that subgroup population. For example, the formula for selecting the disproportionate stratified sample is n equal to small n by capital N. So let's assume that we have 30 population. From the strata 1 we have 12, 12, 12. We have to select, and first group contains 6 people, the second group contains 8 people, the third group is containing 16 people. So according to the subgroup size we have selected the sample. But in the disproportionate case, irrespective of the population in the subgroup, we are selecting 4 people from each group. Say we have, this is the population, we have made strata like this, maybe different age groups of male or female. Here this is a disproportionate stratified sample. From each subgroup, we have selected 3% irrespective of the subgroup population size. Next, systematic random sampling. When the complete list of the population is available and from which the sample has to be drawn, the systematic sample method is quite popular. In the systematic sampling method, the first sample has to be selected at one unit at random, and all the other items are numbered, serially numbered, and then selecting the additional units at every spaced intervals until the sample size has been reached. In this case, the sampling interval is very important. As we said, the first sample has to be chosen in the random selection, and the other units has to be selected in the uh, um, interval basis. The sampling interval here is k equal to population size by sample size. Let's assume that there are 12 people in our population. So as per our sampling interval, we have to go for, let's assume we need 4 sample. So population 4, so we have to select 4 people with the 3 intervals. So we have selected second person randomly, and then the fifth person, eighth person, 11th person. So in this case, every third person is systematically selected as samples. Next, multi-stage sampling or cluster sampling. The random selection is made of primary, intermediate, and final units from a given population. So several stages of sampling process is carried out in this sampling method. The first stages units are known as first stage units, are sampled from by using a suitable method, maybe simple random sampling method. And the second stage is known as second stage units, and again the each of the selected units from the first stage. Let's assume that there are out of these many states, there are different A, B, C states are selected for the study, and out of these states we have to go for the districts, and the districts has to be selected again. Uh, Out with that, within that districts we have to select the villages of these uh, of a particular maybe A state, and in that village, how what all the households we are going to study. Say let's assume that out of this 3 states we have selected A state, and uh, in the A state, there are districts and villages as selected, and these are all the households finally selected for our study. So this is first stage, second stage, third stage. This is the final stage of our units. Next, we are going to understand non-probability or non-random sampling methods. First one, judgment or purposive sampling. What is judgmental sampling? It is, as we said, the non-probability sampling does not give equal chances of being selected in the sample. So the researcher selects the units to be sampled based on their knowledge or professional judgment. So the choice of sample items depends purely on the judgment of the investigator. Uh, he or she includes those items or subjects in the sample which he or she thinks are the most typical of the universe with regard to the characteristics under investigation. So, quota sampling. It is also a type of judgment sampling. Quota sample. Here, quotas are fixed according to the some specified characteristics, example, income groups, age groups, political or religious affiliations, and it goes on. And then you can interview, the researcher has to interview certain number of person which constitute his or her quota. So within the quota, the selection of sample items depends on personal judgment of the researcher. So that's why this is known as uh, non-probability sampling. So let's assume that this is the population, and the quota, the red color persons are between 22 to 31 years. The three numbers has to be selected, and green color 42 to 51 years. Three numbers has to be collected. So this is the quota, and that is it's similar, like the quota sampling. It's same like stratified sampling. So because the population is divided into pots, and the total sample is allocated among the parts. Of course, the two procedures are different because in the stratified random sampling, the samples are chosen from the random from based on random selection within the each strata. However, in the quota sampling, the selection is not random. It is purely left to the interviewer to decide who is her or his sample. Convenience sampling, it is also called chunk. Uh, it is purely obtained by the researcher from the population units. Uh, basically, is basically it depends upon his or her convenient. So it is also known as chunk. It is the fraction of population being investigated the um, by the researcher is not based on probability or nor by judgment, but purely by his or her convenience. So let's assume that this is the population of a, uh researcher. uh, the researcher selected only 4 people out of the population because he or she finds that this group is near to his or her maybe residence area or near approachable area. So these four persons are convenience samples. However, it is important to note that in this group, the purple figure is not in the sample. So it can be like it can create biased results. Snowball sampling or chain referral sampling. Snowball sampling is a non-probability sampling technique that is used by the researcher to identify potential subjects in studies where the subjects are hard to locate. That means when the sampling frame is not available, the researcher may use snowball sampling. The snowball sampling is defined as a technique for finding research subject. One subject gives the researcher the name of the another subject, and who in turn provides the name of the third, and so on. For example, let's assume that this is the first subject or unit of the uh, population we have identified, and this person is referring this blue color person, and he is also referring this person, and these two are again referring few persons, and these persons are referring some other persons. That's why it's known as snowball sampling or chain referral sampling. It's look like a chain, and these people are referring the next follow-up subjects. Thank you.